have a worksheet today and tomorrow. Yeah. Today's lesson, I said, is going to be a little bit longer. Tomorrow's lesson will be a little bit easier, okay? And so if you don't finish the worksheet today for homework, please try to, but if you get stuck, then you can work on it tomorrow as well, okay? We are graphing exponential functions, which are a different type of function. You guys have graphed linear functions, okay? That was graphing y equals mx plus b. Do you remember that? Yeah, B for begin, and you would graph a line and count the slope. So we have graphed linear functions. And today we're going to look at exponential functions. And exponential functions are so named because they have an x literally in, see how it's in, the exponent. See that? X in the exponent position. So I'm going to show you one. Here we go. So this is what we're going to do first. You can always graph things by making a table of values. It's a fail-safe method. Please, you're writing this down. Make a table of values to graph a function. Now, we're going to do a table of values for the first one. But I have to ask some extra questions for you guys because we haven't graphed like this yet. All right, so today is kind of interesting. You'll notice here, this is our function y equals 2 to the x. And you'll notice that the x is in the exponent position. This is an x up high. It's a raised x, okay? Which makes it exponential. When the x is in the exponent, it's exponential. And it has a different shape than the lines that you guys graphed first semester, okay? So we're going to start by making a table of values, and I'm just going to do an XY chart. And let's start with, what's the first number you think of?
1.
1? Okay, do you ever think of 0? No, you start with 1. That is natural. That's why it's called a natural number, because like your first birthday is the first one we really, right? It's like, yeah. So what we're going to do is we're going to plug in a 1 in place of the x. So we get 2 to the first power. What is 2 to the first power? 2. Hey, great. Okay. And if you plug in a 2, then we're plugging in a 2 for the x. That's going to be 2 to the second power. What is 2 to the second? 4. Good. Great. Okay. And let's plug in a 3. And so we would have 2 to the third power. What's 2 times 2 times 2? 8. Very good. I just want you guys to know today, you are doing the exact same lesson as Algebra 2. All right. Hey, how about that? Same lesson, same homework as juniors. Craziness, huh? Yeah. Which basically just means it's really easy. All right, here we go. Let's plug in some other numbers because just doing positive numbers is not totally enough.
Sorry.
No problem.
When you create test corrections, you have to create a separate assignment with the same skills, correct?
No.
Or they just initialize them on their own?
No. You create a test correction and you link it to your previous test. So there's your file for that. Yeah. All right. Let's also plug in 0. 0 is so important. What is 2 to a power of 0?
1.
Are we sure?
Yeah.
Yeah? When in doubt, what could you do if you weren't sure? You could use your calculator. Hey. All right. So 2 to the 0, you can plug it in, and we get 1. How about that? Any number to a power of 0 is 1. Super. Now, we've got positive numbers. We've got 0. What else do we need? Negative numbers. So let's plug in some negative numbers, like -1 and -2. What's 2 to the -1? Ooh, not -2.
1 over -1, so you do 1 over.
1 over. Yes, very good. Negative exponents are unhappy, aren't they? What do they want to do? go down to the fraction form. So 1 over now 2 to the happy 1 is 1/2. Great. Maybe you didn't remember that. What could you do? Use your calculator. So, ladies and gentlemen, let's just make sure we all know how to do this on our calculator. If you do 2, and you're all number punching your calculator, to the -1 power, and then you hit enter and you see a decimal. That's not what we have. How do we fix that? Math bracket. Math bracket. Math bracket, ladies and gentlemen. Do you all see the 1/2 now?
When I put it in my calculator, it just says error.
You are not using a negative. You are using subtract. So you got to use the negative, not subtraction. Okay? Anything else? All right, y'all got it? Anybody not get it? Okay. Let's plug in a 2. 2 to the -2 power. What does that turn into? 1/4. The negative exponent says, hey, make me a fraction. So it becomes 1 over 2 squared, which would be 1/4. Hey, look at patterns. Oh my goodness. Positive numbers, we got nice big numbers, a 2, a 4, and 8. But when I make them in negative land, they turn into 1 over 2 and 1 over 4. What would happen if I plugged in -3?
1 over 8.
1 over 8. I love patterns, don't you? Okay. Makes things easier. Yes, it is. Okay. So let's make a little sketch here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. Great. And all we need to do is plot these ordered pairs. 1, 2. So 1 on the x-axis, up 2. 2, 4. Would be 2 on the x-axis, up 1, 2, 3, 4. 3, 8. Oh, that's way up here. You can just float it up there. It's okay. 0, 1. 0, 1 is right there. -1. Ooh, -1. How do I do a half? In between. Yeah, 1/2 is halfway between 0 and 1. So it's just up a little bit. Where is -2? Up a quarter. What does that mean? Where's a quarter?
It's like right in between the half.
Yeah. Yeah, it's in between the half and the 0. It's just super tiny, 0.25, super small decimal. And then -3 1/8 is even a smaller fraction still. That's kind of interesting. What is it, do you think, if we were to plug in a -4?
It would be like 1/16.
1/16 is correct. Yeah, it's 1/16. And then it would be 1/32 and 1/64 and 1/128 and 1/256 and 1/512. What are happening to those numbers? Smaller and smaller and smaller and smaller. So very, very tiny. Tiny and tiny and tinier fractions. Is it ever going to get to 0? No. That's kind of interesting. Forever, right? It's going to be like 1 out of a million. And 1 out of 10 billion. And 1 out of 297,867,000. I don't even know beyond millions what comes next. So we're getting closer and closer and closer to 0. Ladies and gentlemen, that is what's called an asymptote. A horizontal asymptote, meaning there's this boundary line, and I'm using my other color here. There's this horizontal asymptote. This is the equation y equals 0. That's the equation of the x-axis, if you believe it. Isn't that weird? Okay. There's this horizontal boundary line that is called, I'm going to write this down for you, horizontal asymptote. A-S-Y-M-P-T-O-T-E. Horizontal asymptote. That really means we get very, very close to this boundary line. But are we ever actually going to touch it? No, we're not. We're just getting infinitely close. Now this graph is very, very tiny, 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 and then it starts growing very, very quickly. Look at that. There's our curve. Look at that craziness. What do you think this is called?
Outlier.
What do you got, James?
Perhaps exponential rate.
Exponential, interesting. It is exponential something. Exponential, what is it doing? Growth, very good. Exponential growth. This is called exponential growth. And the nice thing is we know it's exponential growth because of this base. This is a base of 2. And if that base is bigger than 1, it is exponential growth. All right? Every single time. Every single exponential function looks like this shape. Now, I like to have special names. I'm the silliest math teacher ever. And I lovingly call this the Superman graph. Have you ever been to Six Flags Magic Mountain? Yes. Is there a ride called the Superman ride? Yes, there is. Guess what? The Superman ride looks just like this. I wonder if I can look it up for you. I didn't do this in any of my other classes, so you guys are extra special. All right. So here is the ride right there. Yeah, where'd it go? Or this is even a better picture. It's sort of flipped on the other side. They're taking it from the other side. Oh, here's one. Let's get big that. Big that. Come on, big that. There it is. All right, so it comes back here to the left more, but then you can see, there it is. Look at how it goes. It's the Superman ride, okay? That's the entire ride. You start down here and you go up and then you fall back down. But that's totally weird. So that's why I call it the Superman, okay? Now, you can also call it exponential growth. That's the mathy name, okay? But I like Superman, okay? Now, here is where we're going to use our calculators, ladies and gentlemen. Get your calculators, please. You must follow along. Hands-on calculators. Here we go. You're going to make sure your calculator's on. You're going to go to the y equals button. I'm pointing to it if you look on the screen. Go to y equals. Press y equals. All right.
My brain isn't like
Now, first of all, I need you to do a check when you're in y equals. Are there equations here like mine?
Yes.
Okay. Then you need to clear. Arrow down and clear. Okay. Now, is your screen blank?
Yes.
Okay. Is your screen blank? Okay. Do you see plot 1 and plot 2 and plot 3? Okay. It is absolutely essential that those are not highlighted. You can see if you arrow up and then you move your cursor onto the plot 1. Can you move it up there? Is it flashing on plot 1? Okay. And if you hit enter, now you'll notice that plot 1 is highlighted. If plot 1 or plot 2 or plot 3 is ever highlighted, you will get an error message when you graph. Okay? Will you please hit enter again, and now it is no longer highlighted. Okay? Now, what we're going to do, you'll notice that our equation said y equals, and we also say y equals. How about that? So we're going to type in 2 to the x. Now, pay attention. Here we go. You have a 2. You have a caret button. And now the x, here's the x. Your x is right next to your alpha key. You see there's an x and a t and an n right there. That's the x that you get to use. Right there. Raise your hand if you have not typed it in. All right. All right. Now I need you to do one more thing so that everything is really, really nice here. I want you to go to Zoom. So push Zoom. And on your calculators, you have standard windows. Rebecca, on your calculator is called V window, as in viewing window, okay? It's a shift function. And we see here a whole bunch of standard windows that your calculator has built in. We want a standard window. You can see it as number 6. Will you arrow down to number 6? And then hit enter. Arrow down to number 6 and hit enter. That is a standard window. Standard window goes from -10 to +10 in the x direction and -10 to +10 in the y direction. Raise your hand if you do not see this picture. Because your plot one is highlighted, you need to unhighlight, hit enter.
I
Okay?
got a different one.
All right, you have something weird in there that shouldn't be there. No. Did you hit enter? Okay. Now graph. You do 2, 6. Anybody else have problems? You didn't type in your equation. 2 to the x. There you go. All right, anybody else have trouble? Okay, so that's the error. Okay, so we're going to do go to. So number 2 is go to. Oh, look at that. We got extra stuff in there. So we're going to clear that. And now you can just. Anybody else? Okay, this is your first experience with graphing in the calculator. So it's important that you get those questions answered. All right, very good, ladies and gentlemen. Look it, we did it by hand and the calculator also did it. That's fantastic. Here we go. What I want to do is develop something here. Y equals 2 to the x plus 5. So, we're going to graph this on our calculator. 2 to the x plus 5. And so what I want you to do is I want you to go back to y equals. So Rebecca, you're going to press exit and go back to your graphing menu. Do not get rid of the equation in y1. I want you to arrow down to y2. Arrow down to y2. And I want you to type in this equation in y sub 2. I want you to type in 2 to the x. Go back to y equals. Arrow down to y2, type in 2 to the x. And then you need to arrow over so you can do the plus 5. Make sure your plus 5 is not up high, but it's down low. Anybody have any questions? You got it? You did get it? Abby, are you with me? I got it. Okay. All right, then press graph. Press graph. What happened? There's another one. Now there's 2 things graphed. True. Huh, this one did what though? It's 5. Hey, it is 5 spaces above. That's interesting. It sure is. It's 5 spaces up. How about that? Okay. Okay, that's kind of interesting. Ladies and gentlemen, will you go back to y equals? Let's go back to y equals. Now in y sub 3, let's type in 2 to the x minus 4. What do you think this one's going to do? 4 spaces down. Okay, so now in y3, will you type in 2 caret x arrow out of that, and then do subtract 4. Make sure you're using subtract, not a negative. Okay? And then press graph. Draw or graph. All right, what'd that one do?
It's 4 below.
It's 4 below. Hey, look at that. 4 down. Cool. How about that? Do you think there's a pattern with that? Yeah, so if you've got a number on the outside, what is that number on the outside going to do? It's going, yeah, all it's doing is sliding it down or sliding it up. That's all it's doing. It is changing it to go up or down so many spaces. That's anything on the outside there tacked onto the end changes it, makes it go up or down. That's kind of cool. Okay? All right. Can you go back to y equals, please, and clear those equations? Clear, clear, clear. And we're going to go ahead and type in this equation in our graph. This is y equals 1/2 to the x. You'll notice the parentheses. Please use parentheses. Okay, so I have a parenthesis. 1 divided by 2. Caret x. Graph it. Oh, that's an interesting graph. What is that? Oh. What is it? What do you think it's called? It's exponential decline is a pretty good name, yeah. It is called exponential decay. Write that down, exponential decay. How do you suppose I can recognize if it's exponential decay? Okay, it is decreasing as we start from the left. It's going downhill to the right. It is decreasing. What in the formula gives me a clue that it's exponential decay? It's a half. It's a fraction. When that b value, when that base is between 0 and 1, it's exponential decay. Interesante, no? All right, this is exponential decay. Now, again, we're going to play with our calculators for a few more minutes here. I want you in y2, I want you to type in 1/2 to the x plus 6. And you'll notice that this is way up high in the exponent. Okay, so we're going to go back to y equals. And in y2, so arrow down, what do you think x plus 6 is going to do to the graph? Is it going to do the same thing?
It's gonna move it up.
Is it? You think it's going to move it up? Okay, let's check. 1/2 to the, now in the upstairs there, I'm going to put x plus 6. So some conjectures here, we think maybe it's going to move up 6. But is this the same thing? Let's see. Is it the same thing as 1/2 to the x and then the plus 6 all big like that?
No. So
These are very different, yeah?
one is moving up and down. Is the other then moving
Side to side, very good, yeah. This one moves up and down. This will move it side to side. Let's see what happens here. Raise your hand if you do not have y2 plugged in. Who does not have y2 plugged in? All right, plus graph. What does it do? Oh my gosh, this one. Oh my gosh, what did this do? It shifted left. How many spaces? Like 6 probably. Well, that's kind of interesting. Is that the way you thought it would go? You thought it would go left 6? Really? I would think it would go right 6. Wouldn't you think it'd go right 6? Does that seem to...
is it because it's half that it moves?
Nope. It's kind of interesting. Huh. Okay, well, if x plus 6 shift to the left, then let's see what in y3, let's do x plus, give me a number. Or sorry, not plus, x minus 3. Okay. So now go back to y equals. And in y3, let's type in 1/2 to the x minus 3. X subtracting 3. Don't use a negative, use subtract. What do you think this is going to do?
Put it to the right.
Right 3. Yeah, okay, let's hit graph. Ooh, yeah, what'd it do? Yeah, it moved it to the right. That's kind of interesting. Right 3 units. Okay. Ladies and gentlemen, here's what you need to learn. And this is all of Algebra 2. We do this so much. You have a number playing on the x. It's with the x, okay? It's up high in the superscript position, and it's playing with the x. That means it's going to shift the graph the direction of the x-axis, and the x-axis moves left or right, okay? So a number with x shifts the graph left or right, okay? X plus 6 shifted left. The minus 3 shifted right. So it's kind of opposite of what you might think, okay? Numbers on the outside move in the y direction, which goes up and down. So these big numbers on the outside move our graph vertically like the y-axis, up or down. And they do exactly what they say. Plus 5 goes up. Minus 4 goes down. That makes sense, okay? And that's what we want to pay attention to today. This graph also has a horizontal asymptote at y equals 0. But here we go. Here's what the real lesson is. All right. The real lesson. Yeah, that was not the real lesson. No, here comes the real lesson. Okay. Okay, here we go. Here we go. We're going to call this the base, not the core. Example 1, graph the core, then shift. Graph the core, then shift. Now, we're not actually going to be graphing using the graphing calculators. That was just your first introduction. I'm going to teach you how to graph these quickly and easily, okay? Example 1, graph the core, or sorry, I'm changing that word. Graph the base, and then shift. And so we're going to do that with 2 colors. And these are my 2 colors, blue and red. Graph the core, then shift. We're going to state the domain, range, and horizontal asymptote, which turns out to be pretty easy. We'll talk about that in just a second. All right. We have our equation y equals 3 to the x minus 2. And know that this is way up high in the exponent position. Its handwriting is very important. Please do not write 3x minus 2 minus 4. Is that the same thing? It's totally different. Okay? Do not do that. This is a superscript. It's big, it's up high, and it's smaller. Okay? 3 to the x minus 2, and then minus 4. Way on the end there. So first we want to do is graph the base function. The very most basic thing. The base, I chose that word because what is the base? What do you think the base is? 3. Very good. That's exactly right. So we're going to graph right here. This is the base. 3 to the x. That is our base. I'm going to call it the base box. Will you please make a box around the base? Base box. Base box. Now, in this model, in this formula, Every number has a job to do. What do you think x minus 2 does to the curve? What does the x minus 2, what does that minus 2 do?
It moves it to the right,
Yeah, makes
2 spaces.
Right 2 spaces, very good. Write that down, right 2.
It makes your brain.
It makes your brain think. Right 2 units. What does this outside number here, this minus 4, what's that going to do to our graph?
Left.
Move it down.
The outer numbers go either up or down. What do you think this is going to do? Down 2. Write that down. Every number in the formula has a job to do. And your
Yes.
job...
They go down 2.
I'm sorry, down 4. Thank you. Thank you. Down 4. Much better. Okay, so here's the easy way to graph. We're going to create a super tiny XY chart. You'll notice I switched colors. I'm back to blue. I am only going to plug in 2 numbers for x. The easiest ones I can think of are 0 and 1. I'm going to use 0 and 1 every single time because they're easy. Okay? And all I have to do is plug them into the base here. The base box, 3 to the 0. What is 3 to the 0? 1 every single time. Now I'm going to plug in 1 to my base box here. 3 to the first is 3. Was that easy?
Yeah.
It's really easy, right? Yeah. Okay, so let's plot those. Plot your base box. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. You'll notice I'm still using blue, and I get to plot these 2 points. Can you tell me, is this base going to be exponential growth or exponential decay? Growth. Very good, because my base is big. Big base here, big growth. 0, 1. 0, 1 is right there. Put a big dot for your first base box point. And 1, 3. What is the shape of this graph? It is a Superman shape. Now, you'll notice I did a little dotted graph there. All I have to do now is take these 2 easy points. You'll notice I switched colors. And now we get to shift exactly how we said we would. I'm going to take these 2 points and I'm going to count right 2 and down 4. So, get your second color here. And I got it on my starter point here. I'm going to count right 1, right 2, and then count down 1, 2, 3, 4. Move it down 1, down 2, down 3, down 4, right there. Plot your point. I'm going to take that other point and do the same thing. Right 1, right 2, down 1, 2, 3, 4. Plot your point. Now, before I go any further, I have one more thing to think about, but I'm almost done. My original base box graph has this horizontal asymptote at 0, where my pin is. But that asymptote also moves with our curve. So it also moves right 2 and down 2, 3, 4. So where is the horizontal asymptote now? On -4. Yes, it is. It is right here at y equals -4. That is the equation of our horizontal asymptote. It's always this outer number, ladies and gentlemen. Once I draw that horizontal asymptote, now I can draw my Superman shape. And the reason I have to have that asymptote there is so that I don't cross it. I only get to get close to it. I cannot cross that asymptote. All right, for this curve, the domain is negative to positive infinity forever. what does that mean? It means that this graph, this arrow, points which direction? It's pointing to the left. Forever, right? Uh-huh. And this arrow is pointing up, but it's also moving outward. How far to the right does it go? Infinity. Okay, that's what that means. How far to the left and how far to the right do the arrows go? It goes forever to the left and forever to the right. It goes forever, left and right. Okay? You'll notice I put the little L and the little R to help me remember left to right. Range talks about how low the graph goes and how high the graph goes. How low does it go? -4. Very good. So we use a parenthesis at -4. How high does it go? Yeah, this arrow goes up forever. So it goes to infinity. All right, that's the range. Ladies and gentlemen, the red graph is this function. The blue graph is just the base, okay? We want the red graph. That's the one we're interested in. All right. You ready to try another one? All right, here we go. We have y equals 1/4 to the x plus 1 plus 2. What are you going to do first?
Find the two easiest x. Add the two easiest x.
I'm going to say box your base. Box your base. Put a box around the base and the x. That is our base graph. Ladies and gentlemen, if you can learn this now, Algebra 2 is just going to be a piece of cake. So we do this all day and all night, every day. This is what we do. All right? And then, what is the x plus 1 going to do to the graph? X minus 2 went right 2. What's this one going to do? Left 1. Write that down. Good. What is this outer number going to do? Up 2. Excellent, ladies and gentlemen. Left 1, up 2. Beautiful. Now we need some easy points to graph. What can I plug in for x? 0 and 1, for sure. What is 1/4 to the 0? 1. That was easy. What is 1/4 to the first power? 1/4. That was also easy. We're going to plot our box base points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is this going to be exponential growth or exponential decay?
Decay.
How do we know it's decay?
Because it's a fraction.
Because we have a number less than 1. Very small base. All right, let's plot these points. 0, 1 for our base, and 1, 1/4. How do I plot 1/4? Yeah, it's 0 in between 0 and 1. It's pretty small. We can't get too perfect. But here is our exponential decay function. Here's what it looks like if you were to put a little dashed line through it. And now we're going to change colors and we're going to shift the base graph. What should I do to these points? Left 1, up 2. Here we go. Left 1, up 2. Now, I can shift my quarter point left 1. And if I shift it up 1, where am I? 1 1/4. And up 2 would be 2 1/4. Very good. Where is my horizontal asymptote? Yeah, it got shifted up 1, up 2. It was at 0, and now it's at 2. So there's our y equals 2. Ladies and gentlemen, that horizontal asymptote is always that outer number. And now you can draw your little decay curve. The domain goes from negative infinity to positive infinity. Always, every single time. Forever left and forever right. The one you have to think about is the range. Ladies and gentlemen, how low does the red graph go? 2. How high does the red graph go? Infinity. Beautiful. Okay, excellent work. Shall we do one more? No, you're good? Okay. All right, I'm going to pass out the worksheet and you can get started. Ladies and gentlemen, when you get your worksheet, what do you do first? Write your name. And then? Box your base. Box your base.